Good morning, everyone.
Good morning.
Well, actually today is one of the more in-depth about the dealer enthusiast class for all the Firenock dealers. If you're not familiar with the entire certified and trained dealer program, is that unless you're actually certified and trained, all the Firenock high-end product cannot be sold through unless you're certified and trained. And then this year we also went through a program. After you've been certified and trained, you're allowed a 50-mile radius of your area. That means all the Firenock aero concept components and higher, unless you're certified and trained, you can't buy it at dealer, even if you're a dealer.
Okay.
Because we find out there's way too many dealers who are not qualified or understand the concept. Until they're certified and trained, we got a lot of customers having product and not getting what they need. That's the reason we started this certified and trained program. But since if they're going to invest the time into this process, we give them a pretty wide area of their own. That's close to a 50-mile radius. But at the same time, we also will enforce the no less than $500 a year minimum product, or up to $2,500 for certified and trained. Because we are going to come out with all the stabilizer system, the aero shaft system. If you can't sell $2,500 worth of them a year, you're not really a dealer. Okay. This is now breaking into, instead of the old 4 segments, it's breaking into 7 segments. The first segment is one of the things that's least understood, which is NOCKS. Most people have no idea how that is. That's the reason we're going to devote an hour on it. And the second segment we're going to talk about is the vanes. The first segment is of the components and how the which is the non-NOCK, non-vane aero components. Then we're going to talk about aero concepts. The 5th segment we're going to talk about the shaft and the shaft construction and what shaft actually do. It's going to go very technical. Don't get concerned you get lost, because I'm putting about 40 to 50 years of knowledge on carbon construction, and I try to do shit out in an hour. And of course, the 6th part is going to be about using the tools to help you to make this happen. Finally, any discussion and hands-on to teach you how to put it together. Okay, each segment is, I figure that each segment is going to be around 50 minutes. I figure that 25 to 30 minutes is about as long as you can hold the duration of concentration. After that, it just becomes a blur. So I'll give 10 minutes between the segments. Okay, now we're going to dig into it and go straight. All right, let's talk about NOCKS. Anybody have any idea how many different aero sizes are now current in the US market? What happens if I tell you there's 29 sizes?
Sounds about right.
Because most people think, oh, I got the 166 size, I got a 204 size, I got a 246. Those are general groups. The 166, there's 4 sizes. Yeah. 1655, 165, 1665, and 166. So if you think about your aero is a 166, and you have 1,500 difference, how are you going to make them straight or fit perfectly? Next thing you know, look at the 204, which is your basic Eastern access, your so they call the 5mm. The industry at this moment used to be all supposed to be 204, but then we all go, that's 202, that's 203, and 204. That's 3 sizes. And the 246 is the worst. Because you like carbon impact is 202, carbon force is 203, carbon express is 244, gold tip is 246, black eagle is 245. If you think about it, that's 5,000 difference. How do you find enough to fit them? And then the good thing about the 300 size, which is pretty much where you start from the vertical bow knock, which is your 300. Luckily, everybody seems to know the 300. But the sad part is that you really cannot buy a 300,000 drill bit that easily. So if you screw up your crossbow or gold tip 22, you can't really clean it because you can't really buy a 300,000 drill bit. You can buy a 302, you can buy a 298, you can even buy a 299, but not a 300. Now, why do I put this segment on the vertical bow now? Because this is the most critical part for shooting in the vertical bow world, which I know a lot of dealers, they all deal with vertical bows. But do you know that at this current market, the number one problem for every single NOCK is not the NOCK itself. It's actually the string. It took me a long time to fully understand. It took me a long time. Because in the old days, what is the original quote-unquote string diameter of a bow? 89, 86. Now you move to 98, 99, 100. Then it's a 105. Do you know what the current, some of the bow like the Hoyt bow, what is the diameter?
Like
137.
Yeah, 137, wow.
Yeah, that's the worst case scenario. In other words, think about the tires. You were told that all tires are 15-inch, and because all rims are 15-inch, and all of a sudden you got rims that showed up at 20, and you try to fit this 15-inch rim on it, make tire on it. What do you think is going to happen? You got pinch knock, you got knock crack, and people say, oh, it is all about the knock, it's not control temperature, the throw. To be frank, you are really into target. 2/1000ths of an inch is all it takes to screw up your knock and your string. 2/1000ths of an inch.
It's like George keeps blowing knocks up.
Yeah.
Let me sort of give you this video, but this shot, this slide will show you exactly what happened.
So 2/1000ths of an inch, you can lose that just in your center circle.
Not center surfing. It's center surfing over 30 shots. Give you an idea. If you shoot, say you get a typical off-the-shelf bow, and it was actually coming in at 125,000. You clip a knock on it 20 times. If the surfing is surfed less than 2 pounds of pressure, that surfing will shrink 8 thousandths. That means your 128,000 become 120,000. But that's not the bad part. The bad part is that most of the string had creep in it. That means when you shoot that bow, the string moves left, the string will move right. What does that mean? The contact of the knock just got tight, loose, and tight. Now which way of the knock is going forward? You do not know. Now to make things even worse, a typical people who make knocks, they went through a 4, 8, 16, 24 cavities. What does that mean? That means when you flow the knocks through those cavities, the one usually do a center flow. Imagine the knocks are like that, all the way up to 16 or 24. The flow is coming from the middle and it goes out. Polycarbonate cure from the outside in. What is the curing time of this knock compared to this knock? From the center point to the outermost. They're different. But then how can we possibly guarantee all the knock is exactly the same size? Even with the current CNC technology at 0.25 thousandths, you cannot guarantee it. Now, as the flow of the polycarbonate change, that means the density of the flow change, the curing of the flow change, and the rolling of the polycarbonate changed. So the moment that's the reason you find out, a lot of times when you got a good batch of knocks, from most of the company we use 4, 6, 8 cavities. Some knocks work better than others. To make things worse, back in about a few years ago, some company called me and said, I got knock break left and right. I said, when do you make them? They say, well, somewhere in November. I said, I bet somebody opened the door. Because just by changing 3 degree to 5 degree in temperature of molding, you change the curing temperature of the knock. The durometer, which is the elasticity of the knock, changed, which means the knock pinch will change, and the knock crack will change. And to make things worse, you remember the old days, all knocks are single color of black, white, yellow, blue, and solid colors. Do you know why? Because see, we understand from the chemistry of plastic, polycarbonate will degrade based on ultraviolet and time. The moment you go solid color, you prevented that. As we know, as I started the company with light and knock, what's the number one thing? The knock need to be, the light? Light must pass through. Second, you need to make the polycarbonate to its best, which means the material is the thinnest. Now I have 2 problems. One is called aging. The other is called ultraviolet degradation. You say, well, I put my knocks in the drawer. I say, well, no matter what, you eventually will degrade based on age. Yes, all the new polycarbonate knocks have a 5 or maximum 10-year age. In my cases, everything over 6 years, I throw. Now, how do you tell a knock is old or aging? Take up a polycarbonate knock, translucent one, which is a good thing. Look through the knock. If the knot looks perfectly clear, the knot is okay. The next thing you do, grab the pinch of the knot like this part right here. Pinch it. The moment it snaps, you would grab just like that. It's time to change the knot. And a lot of people say, oh, you still look good. No, you don't. If you are not care about winning or shooting your trophy animal, go for it. Next thing you know, you find an arrow in your arm or you do a dry fire. That's what happened. The knot is the cheapest thing out there. But then people will talk about, oh, well, what is so big deal about how do you circumvent all the problem about knot pinch, aging, and also difference? There's only one way to do it. At this moment, there's only 2 companies on the whole planet do this. It's Firenock and Vital. We both use single cavity, single mode. What's the benefit and the downside of this? The downside is that when every machine, ka-chunk, have 8, 16, 24 pieces, I have 1. But can I guarantee consistent of that 1? Absolutely. Now this is where the difference between my NOCKS and all the rest of the world is that all my NOCKS are polycarbonate, virgin flow, no grind, no regrind. What does that mean? If you look at a lot of companies, we grab the knot and look at it, there's some black dots and bubbles in it. You know why they have that? Because when you come with a knot, that flow piece, all the way to the knot, you need to cut that. That piece of plastic, a lot of companies throw it in grinding and put it back. That process introduced bubble, introduced dust, and the flow of the plastics are no longer accurate. Now, polycarbonate, like other material, have very unique process. The curing is the inside from the outside in. That means when you cure the polycarbonate, the inside of the polycarbonates are always soft. That means you got a set of exoskeleton. Now this is where a lot of people tell me, oh, Dodge, your knot is so tight. My string is 120,000, you make a knot is 115,000. I just put a file on it and take 5,000 out. It is like you just decide to shave the shell of an insect. What do you think is going to happen to that thing? It's dead already. I say, well, it works perfectly now. What's perfectly now mean? Remember, polycarbonate at 4 degrees will turn into the property of glass. If you shave glass or you score glass, what are you introducing? Cracks. As the temperature drops, what do you think is going to happen to those cracks? That's the reason you find a lot of people who shoot lighter knocks during just after November season, the knocks are cracking left and right. Especially for crossbows. Because you got so much power coming down on polycarbonate knot. If the knot is not perfect, now remember, just like glass or crystals, they are perfect if you apply power. There's nothing going to happen. But if there's scores or crack on it, it's going to all over the place. That's the reason I always tell people, find a knot company you like, stick with the size you like, and find yourself a good string maker so that you know exactly what your knot and string interact. But then say, well, you know, and you start knowing about strings, this is where the critical part is. As I said, most strings in the market is not round. Give you a hint, every single string until specialty archery comes out, every single string made are oval. Do you know why?
Because of the loop down the...
Because the loop runs like this. When you push it down to the lower, you increase the speed, decrease the speed. And the average bite out or any single loop out there only give you 1.5 pound to 2 pound pressure. That's when I discovered this in 2016. I invented arrow bow serving jig. Right now, all the major guys are using it. As a matter of row string are using it on bow serving. They're putting 26 pound pressure on the serving. That means now you can put a 28 strand fiber, put 22 pounds on it. You end up with using 16,000 Angel Majesty. You can get 115,000 on the OD. Guess what happened to that string? That string is absolutely perfectly round. Now let's take a very close look at this part. I want to emphasize this. See this throw right here? See how round this is? See these 2 edges right here? This whole process is patented. I patented that in 2006, but nobody understands this. This design alone will give you 1 to 2 feet per second faster on the same identical arrow. It's called a shear system. That means when that arrow and knot interact or relieve, there's only one point of release is either the left or the right, not both. Now, why is that throw so critical? See, if you take a closer look, I actually show you the design diagram. That throw is 2.8 millimeter, which is 115,000. But 115,000 with 1.5 degree coming in because of mold construction. In the very throat, you also notice that I especially put down the G-NOCK, the A-NOCK, and the S-NOCK. People say, well, aren't they all 2.8 millimeter? I say, yes, they are. But you also have to deal with the fact that NOCK height. That means the total contact surface is different. The G-NOCK have close to 3.35 millimeter, and the A-NOCK have 3.5, and the S-NOCK have 5 millimeters. Those are all different design because of the diameter of the arrow and what you want to grab the arrow. Now, when you're doing a 3D, why would a lot of people think, oh, I'm going to use an S-size arrow, which is 246 ID, with close to like a basic 400 spine 246 ID arrow. And at that moment, they decided to put a bushing on it and actually go with a G-NOCK. What do you gain and what do you lose? The G-NOCK will give you a 3.35 millimeter contact surface, while the S-NOCK will give you a 5 millimeter contact surface. A lot of people are using the G-NOCK because of less contact with the string, but you also make everything more critical. Now, G-NOCK is shorter than the S-NOCK, but you do speed shooting, the S-NOCK is better. So a lot of times, it's not what the NOCK you want to choose, it's what the NOCK you want to perform for what you're shooting. So if you do a Buckmaster, like an outdoor sportsman group, the S-NOCK is what you want to use. If you want to do a 3D on 246, okay, the A-NOCK is what you want to use. You want to do indoor with a 246, the G-NOCK is what you want to use. Now, even that itself has difference. Even the contact surface is based on 2.8 millimeter. The height is a little bit different, but there's one thing you can do. For you to find a good string maker and fully interact with the string maker. Just like, okay, I'm shooting 3D, I'm shooting indoor, okay, prong rest, G-NOCK, what is your string surfing size? Your string surfing should be 0.108, because at that moment, your prong rest has zero effect on it. You want your arrow to sit on it. You want to have at least 7,000 play for the NOCK because of the string angle. That's the reason at that moment, use 108. Now, the moment you do indoor 3D, you want a little bit more control. That's the time you use 110,000. The moment you go into hunting situation, depends on hunt and spock and stock, you go and push 115,000 to 120,000. See, people say, oh, this is so critical. I say, don't think of it as just archery. Think about it, every single component, just like you do race cars. Shaving a tire, another 3,000 going to a corner will make all the difference in the world, unless you're not interested in winning. But this is where the critical part is that most people don't understand. This is on the technical side. Because until you got the technical equipment set up, it's just like racing. You've got the driver, and you've got the pit crew, and you've got the guy who built the engine. What I'm teaching you is what the guy built the engine. After the engine is built, after the chassis is set up, then we've got the guy who set up on the course, and then finally you get the mental ability of the driver with it. But until you understand this part, now you're relying everything on the driver and the pit crew to get it fixed. Because sometimes you can't fix something. The NOCK and string is one of the things that most people can't fix because they don't even understand it. The problem is not in the NOCK, the problem is not in the string, the problem is both and how they interact. This is the part I want to sort of drive it home because most people really do not know this. They thought a string is a string and NOCK is a NOCK. No, none of them. The big deal about today's bow is that today's bow is no longer the same. Just 15 years ago, the bow are not what we have today. We're pushing 80-something% efficiency. The angles of the NOCK pinch is ridiculous. Now you can't even shoot a NOCK if you feel like it, a knocking point. You know that the NOCK will fall off your string. You have to stick a string loop. So the technology has shift, but at the same time, a lot of people like myself have discovered this issue. That's the reason you see companies like Specialty Archery, you see all the specialty string coming up. But unfortunate part, a lot of people do not understand what they're buying. It's like I go to a string maker and say, I want a set of hoist string for my Defiant. The question is that for what and what knot you use. It's like I want a set of tires for my truck. What truck? What size? What do you want to do with it? Those questions were never asked. You notice that? But those are where the difference is. I mean, in my cases, I even show you. See that right here? If you progress 108,000, 110, 112,000, that's so simple. It's there, but nobody take the time to look at it. But then at the same time, when you use an ordinary, I'll say a lot of shop reserve. When you reserve, what pounds are you reserving? What material are you reserving? Is the material actually round? Is the string actually under pressure? How much wax is on the string? All those make a big difference because it's just like, you just go to a local Firestone and try to put a tire on and you want to drive 130 miles per hour, I can guarantee the car will shake like crazy. Because the guy have not taken into all things into consideration, which will go into the second and third part. I will tell you how big a deal that is. Because as our arrow speed increases, especially, I start from the crossbow world when I learned this. At 250 feet per second, this is no big deal. But when you're shooting 460, 480, 505, 515, trust me, everything matters. And it matters a lot. Any questions so far?
So this presentation, we'll get, between the video and the presentation, we'll get copies so that we know.
No, actually, you see the whole thing.
Yeah.
This whole video is going to be on YouTube. And then, of course, now, this is pretty much a vertical bow. Now, you know the vertical bow, as I said, there's only a few major ones. Eastern make it simple is 4, 5, and 6 millimeter. That's the general, okay? Then we also have the crossbow size, which I call it go to 22, which is your G knock, your A knock, your E, which is your H knock, and your S knock, which is 4.
Yeah, so I have mine made to 110. And my guy makes them, and I usually tend to use mercury or a natural without the wax in it for my string.
Which is good.
Now, I've got some of your NOCKS from the GT22s and stuff, and I've got to ram those things on there, and they go pop, but it doesn't look like the ears are coming back, even at the 110.
Well, that depends on, if you actually surf, and if you look at it, it's truly 110, that is 110.
Yeah.
Now, if the ear is not coming, then it has to crack. First of all, the whole process right here, you see that right here? That's changed right here. This is where the pattern process right here. See, this is actually half a degree offset.
Yeah.
So in other words, the moment past this point is no longer touching. This whole knot is actually utility patterned in 2006 by me.
Yeah, the ones I have are your A's.
Yeah, the same thing. You know,
Yeah.
this throw and this throw is identical. The only reason this is thinner because the G knot, if I put a prong like this, you'll start breaking right here. Because it's too long and too flimsy.
Right.
So I would say unless you go 115,000 now, another thing you need to look at is that when you think the knot is that tight, it cannot be right. That means you look at it. You need to put a knot on it and rotate the entire knot 100%.
Right.
And see whether you got 110,000 somewhere. Because remember, most strings out there are not round.
Right.
They're actually oval. So it depends on how you sit it. And that's another problem. A lot of dealers of mine will tell me, hey, Dodge, you know, halfway through the season, the knocks are cracking left and right. A lot of people like to carry the bow with their hand, like this, one of string. Their sweat go depositing on the serving. Temperatures start dropping. Guess what the sweat become? Salt crystals. And the salt crystals start scoring the inside throw of the knock. The moment the temperature dropped, guess what happened? They cracked it. That's the reason I always tell people in a hunting situation, when you shoot an animal, recover your arrow, but don't even think about it. Change your knock. Because I give you single cavity, single mode, all the knot will click on identically, no matter what color it is. And yes, if you start shooting prong rest, you need to drop the serving to 108. Because now at that moment, you want the arrow to have free play between the knot and the string, but not lose it.
So how much pressure should you have on the knock and the string as far as for it to eject off of the...
Usually when you hold the string totally,
pluck?
on the change of a prong knot, you're able to hold the string and slap and then tap the string. No more than 2 inches, the knot should fall off.
Okay.
On a 3D course, usually able close to 6 inches, you snap the string, then the knot will fall off. Okay. Anything sport hunting and so on, you have to physically shoot it to come off. Okay. Because the last thing you want to do is that when you pull a bow back, the knot fall off on your trophy hunt. All right, that's pretty much concluded our vertical bow NOCKS. Now we're going to something that everybody thought is the biggest deal for the last 4 years. It's the crossbow NOCKS. The crossbow NOCKS is such a big deal, and actually it makes such a huge situation because as crossbow speed increasing, the NOCK become more and more critical. You notice that I segment that in 2 segments. The one, the CD, D2, F, J, M, Q, and U is on one side and Y is on the other side. Because when they make crossbows, that is 2 diameter they are. The crossbow arrows have an unspoken standard. You don't exceed 350 thousandths on the OD. 335 is what everybody should. So what happens if you use a cheap material that don't have much strength? The only chance you have is increase the wall thickness, isn't it? And in most cases, right now there's 3 major crossbow sizes. Of course, there's minors. The first one is the old military standard made by Vapor. That's 270,000. There's only about 2 arrows in the world that use that. The Crossfire and the gold tip laser for kinetics. Then the rest, the next one you got is the Carbon Express, all Carbon Express crossbow arrow, and also the Eastern Full Metal Jacket. Those are 285,000. The rest of the arrow are 298,000 to 303,000. The funny part is that if you look at 2219, the ID is actually 303,000, while the 216, the ID is 206,000. While the rest of every single crossbow carbon arrow in the market, besides Carbon Express and also some of the older gold tip, are 300,000. But that's really confusing, isn't it? We're not talking 2,000 or 3,000, we're talking 7,000, 8,000. So under that condition, I have come up with this is the solution now. And before the crossbow become even faster, we have this form of crossbow, which is your typical flat knock and your moon knocks. Flat knock have a lot of benefits. A lot of benefits. It's extremely forgiving, extremely accurate. You don't have to think about it. It's traditional way. But there's a lot of downside to it too. But if you're a casual shooter, once in a while you want one, not more than 70 yards, the flat knock is your good friend. What I did is that you notice on the left-hand side of this design, the flat knock and the moon knock have 2 grooves on it. See that? That means I'm able to put O-rings on this groove and cover 304,000 all the way to 297,000 by just changing the O-ring size. And now, of course, a lot of customers on the older school still like 222/16. That's 306,000. That's 6,000 bigger than a normal arrow with a super thin wall. People like them because they recognize that the arrow is light, the reaction time is fast. If you don't shoot over 60 yards, you don't shoot over 350 feet per second, the 22/16 is a fantastic arrow because it's an aluminum arrow and the spine is linear. On crossbow, you can't ask for better than that. And furthermore, it's cheap. So we actually, if you call us specially, we'll give you the O-ring to fit that. Now, on the case of the on the Carbon Express and also the Eastern Full Metal Jacket, you notice 285,000. That is the only one that will work. Now, you also notice that the head of that knock is significantly taller. Because see, in those class of arrow, unfortunately, they are made of fiberglass. And Eastern's, of course, it's not, but you got a Full Metal Jacket. Using a fiberglass arrow, you want to sort of like cushion the extreme shock. That's the reason when I design a Y knot, I do 2 steps. First of all, I make the knot longer. Second, I put a dimple on both sides, a really big dimple, so it actually behaves like a spring. So when the Carbon Express, like 250-pound bow, slams in the knot, you cushion the knot a little bit and forward without cracking the shaft. Now we go into the part that all the new high-speed generation crossbow come into life. I patented this process. I mean, you notice some of them are really old, like the old Jennings Devastator back in the 1980s. They use something very close to the D2 knock, the D knock, which is 300,000 ID with 165,000 serving. How come there's a D and D2? You notice every single one of them look different? Let me sort of run it down for you. The C knock is to handle 125,000. The D knock is handling 165,000. The J knot is 155,000, the Q is 145, and the U is 135,000. Well, how come there's so many sizes? Good questions. How come people can't agree? They don't. The industry as a whole on the crossbow world is 125,000 to 165,000. That's the range. And I'll give you the rundown. The C knot, which is 125,000, currently the C knot is used for bow tag and some of the new Ravens. The next size you see is the U knot, 134,000 to 135,000. Now remember, the number I show you is plus and minus 5,000 max. So I cover the entire spectrum. The U knot is based on the older R9 and R15 Raven. But unfortunately, the string is not great. So although the string is 134,000, after about 50 shot, you look at 127, 129,000. So lost 5,000 there. And then you look at the Q knot. The Q knot is what I designed for Scorpet. And find out it was the same size you can easily use on Parka. And then you go to J knot. The J knot is 155,000. That's the best knot for your 10-point, your Wicker Ridge, your Matthew MXD, the sub one, and also the Hortons. And finally, the D knot. The D knot is what I use for Tech 15 and the Jennings Devastator. How come there's a D2 knot? Well, unfortunately, original when the PSC decided to come with Tech 15, it followed the original Jennings. The ID is 298,000, not 300. So when I make the D knot for 298,000 until they stop making the arrow. So what happened to all the tech guys who want to shoot it? Well, they have to get a 300,000. And when you start shooting 415 feet per second, that 2,000 make a big deal. So that's the reason there's a D2 knot. Now, the next slide was going to be quite interesting.
What do they shoot on the CAMX?
I'm not sure.
The CAMX is a flat knot.
Flat knot?
The CAMX is already a flat knot.
Yeah.
The new CAMX design is quite different. I mean, I look at the design. It is, how do you say, it's a reverse draw cam without violating the pattern of the Scorpet. It's a very efficient design. It's a true standard design.
Yeah.
Well, anyway, let's go back to the CJ and U knot. You know, this knot is extremely different from any knot out there compared to a normal knot. That is because as the crossbow speed increases, the pressure increases, the need of safety increases. So you find out all the anti-dry fire for all the knocks are right behind the knot. That's the reason you can't have a long prong. Because if you do have a long prong, this is what happened. This is your knock. This is your string. That's your anti-dry fire. Your string ends up being like this. The moment you shoot it, you got a mini dry fire to start with. That's why you crop the knock, slam the knot into the string, and you the arrow and split the shaft. That's the reason when I actually, this is under my design patterns. Quite a few companies try to violate it, and I go after every one of them. Finally, people say, well, why do you need so many colors? Good question. Why can't every single car be black? But then there's a real usage behind it. As you guys start shooting, you find out that different humans pick up different colors, especially colorblind customers. What I discovered is that the best colors are all in the red spectrum. The red, pink, and orange is your favorite. That will work with any human being under any conditions. As the time getting dimmer and dimmer, your green and yellow get good. The moment there's no more light, the blue become king. White is the worst in all conditions. You say white is the best. White is the best if you want to shine a light at something and look at the reflection. In the case of the lighter knock, you're looking at the light. People say, well, you know, I target shoot, I never need lights. This is what happened with the NASP and 3D courses kids. They have extreme problem because a lot of times they hand talk like you don't believe. And you can tell them all day long, they will never believe you. Oh, I'm perfect. But then you notice that the moment you throw a target lighter knock on them and they see the light going like this, they say, see that light that goes out? Shoot that again until the light is straight. Within half an hour, the hand talk problem disappeared. I mean, the St. Louis group of people that I teach this approach to, all the kids hand talk within half a day, gone. Because they can see it. There's no argument. Oh, I will put video on it. No, I didn't. No, you did. Because that's the reason I tell people, always get a 2 or 3 target lighter knock, so when you shoot it, you see how the light come on your bow. Because just in case, if something went wrong, you know. You may lose 1-8, you may not win the championship, but at least you are in the play.
We don't want to put those on your, on your arrow plate.
Hey, my rebel's too good.
Now, as you find out, the moment you go to colorblind customer, the funny thing is that depends on what colorblind. People say, oh, I'm just red-green colorblind. Not exactly. Even that has differences. That's the reason I actually have similar light boxes for customer to see outside the light, inside light with no light. Because when you use indoor and outdoor, that's the reason you see for the last 6 years the Buckmaster competition, every one of them use mine. Because you know exactly what's wrong with it. When you want to shoot 6 targets in 10 seconds, you want to know your bow is perfect. You want to know how everything goes. This will help. Now the next topic we want to talk about is temperature. People say, well, you know, temperature is not a big deal. No, temperature is a very big deal. Temperature change your string, temperature change your bow, temperature change your knock behavior, and temperature for sure will change your lighter knock behavior. As we are finding out, you know, we make lighter knocks. And right now, we sell 4 batteries, 3 plus 1. The 4th battery is only by request. The 4th battery is called a BX battery. You handle 55 below. Those are $125 for 3. Because I have to ship the damn thing in dry ice to where you hunt. You're not going to carry that piece of dry ice on the planes. They won't let you. So I have to FedEx it. Then you look at the 3 batteries currently. There's 3 separate chemistry on it. The BR battery handles 17 below all the way to about 80 degrees. The BR battery handles 4 below to about 180 degrees. See, nobody hunting 180 degrees. I say, imagine you're in Sahara, Africa, with your arrow on the back of the truck, the sun shining for 2 hours. What do you think the internal temperature of your shaft is? Because you're cooking the battery. And finally, we got the BU. That's a very, very old battery. That battery came out in 1976, made by Panasonic. The gentleman of Panasonic love fishing, and this battery have a 0.5 degradation per year. So I got some battery I bought in 1977. It's still good today. All right, so this
What's
is
the temperature range on the BU?
The BU is -4 to about 120. But that was a major difference in the capability. The BL is 30% brighter than BL. The BL is 30% brighter than BU. So BU to BL is about 50% brightness. And the BL battery, the way I designed it, is that using a red knot with a red LED is visible up to 2 miles in total darkness, or 120 yards in broad daylight. Those are the original military spec when I designed this. Because see, the Firenock back in 1990s was used for military, for instant one-way for the Marines. You actually shoot it out of area, and you land the NOCKS on the ground, and you land the plane with it. So that's the reason those are the specs we have. Now you know why everything is IPX compliant. And finally, this is the part I think that you want to spend a bit more time knowing. This is the entire chart that we have. Now you know why we are able to make 17,000 versions of lighter knocks and how each knot interacts. We actually make 13 sizes of knocks. We make 42 different computer circuits. We make 4 different batteries, and we make the end caps, O-rings, and so on. Why so many? Well, there's so many different bows, arrows, shafts out there. And then we make different computers. Like the hunting circuit, the Firenock hunting circuit, red on red with a BR battery under -3 degrees will lead for just under 366 days. So just after over 1 year, it will still lit. The Firenock blinking circuit will blink for a normal temperature of 7 degrees, about 2 weeks. And then for the target guys, on 3D guys, the Firenock target circuit, they will lit for 17 seconds and shut off by itself. That pretty much wrapped up the NOCK side. Any questions?
No.
That's a lot more than you thought, isn't it?